Cool. Can you all see my screen? Can everyone see my screen? Yes? Okay. Great. So we were talking about salary prediction, right? We all are a part of Tutort now, and we all have a lot of interns with us who are interning with us. And herein, we want to predict their salaries. We want to predict their salaries for their upcoming drive. And why we are trying to do that? Because right now, the students are clueless, right? The interns are clueless that what is the upcoming, what is the upcoming placement drive going to give us, or what is the upcoming drive return for us, how much benefit am I going to get from it, or what is the salary package right now I am eligible for, right? So for example, I'm a starter and I'm expecting something around 7 to 10 LPA. If I can predict, and if my model can predict as accurate as possible, and if I can give a number to this intern, and he knows that for the next upcoming placement drive, he can expect somewhere around 10 to 12 LPA. That person knows that, yeah, I am ready for this. But in case that person has an aim for higher salary, and of course it should be like that, then the person can know what are the areas that he can improve on, right? And we are going to give them recommendations as well. So we are going to get them build a personalized dashboard which gives them the whole scenario of their status, which gives them the whole scenario of what is going well, what is not going well, what is the upcoming drive going to give them, how much salary package are they going to get, and what are the recommendations for him or her to upskill, right? Everyone with me till this problem statement understanding? Yes, can I get a yes if everyone is with me till here? Okay, cool, great. Last time we were talking about exploring the data and we were talking about understanding the data. So just to start, I think I had given an assignment to everyone to actually put across their story through a presentation or through a doc. But I couldn't see any submission for the same. Can anyone tell me why so? Like why none of you guys were able to submit anything? Is there any blocker? Is there any problems that you guys are facing? And you can even unmute and speak. So please because see, at the end of the day, we are building this for you, and we are building this together, right? So I want that you can use this project in your placement. I want you to include this in your resume, and I want you to sell this off in your interviews, right? So at the end of the day, it is only going to benefit you. So again, if you do the work, only if you go through the project and you build it on your own, will you be able to own this project, and will you be able to speak about it in your interviews, right? So for you, we have a lot of tasks, right? And this was the task one of it. So can anyone tell me why, or what is the issue, or any blocker that you're facing that you could not start or drop the assignments? Or did you guys even start with it? Can I get a yes or no if you started with your presentation? Couldn't able to upload. Okay. What about others? I'm expecting a response from everyone. So can I get a quick response? If you want, you can unmute and speak as well. But feel free to drop your responses because we are all here to grow. We are all here to learn. And yeah, we are going to collaborate and do this together, guys. So yeah, please let me know what's the blocker that you're facing. Weekend was busy. Okay. And what else? What's the blocker? Started but couldn't complete as there were other classes over weekend as well. Didn't get a clear idea to display on the assignment. Okay. Okay. So as far as I can understand, this is more of a time management or presentation management problem statement, right? Now, if for people who are not understanding how to present it, you can maybe start with just defining the problem. Forget about presentation, forget about anything. Just open a doc and start writing what is the problem, what is the objective, what is your current state. Write just write 3 pointers. What is your current state? The current state is that interns are working with Tutort to solve multiple problems and upskill themselves. Interns have no idea about how much they can aim for the next upcoming placement drive, and how much they are eligible to earn from the next drive. And the third point is maybe interns that don't have an idea on what are the points to upskill, or where are they lagging themselves from. So this can be my current state, and we again know about the future state as well. Yeah, exactly. We have to basically describe the data story over here. We just have to describe our state, our objective, and the gap. And then while we are doing the project, like last class, we built a lot of hypotheses, we tested them out. So we have a lot of insights with us, right? So we are going to write them. We are going to write that, you know what, actually years of coding is mattering a lot over here. So this is a good insight for the interns, and they can start building on their coding experiences even more. So that is like one of the key major insight, right? So something like that. And if for people who are not being able to upload, you can also mail it to Tutor. That will also work. So, but did you guys get an idea about what are we trying to build? Can I get a yes? Can I get a yes if you did, and if not, you can tell me as well. Okay, I think we are lacking behind for response. So the faster you respond, the faster we are going to go ahead with the class. So please let me know if you understood what are we trying to present and what are we trying to create, right? Yes or no? Did you guys understand or not? Yes? Okay, great. Yeah, great response. Thanks for responding, right? Cool. So now that we are done with this, I think a lot of people might be having a lot of questions around how do we progress with the project, or how do we use this project on your for your interviews or for getting noticed by recruiters, right? So again, we have multiple paths paved for you, and personally customize them as well. Now, for you to own your project, obviously you have to do it on yourself. Along with me describing the project for you and helping you navigate through the project, you are expected to do the project yourself after the class ends, and also complete the task, right? So for example, we build a model today, right? Once we are done building the model, I expect you guys to go back, see the session, learn from it, and then build your own model. It doesn't matter what your accuracy is, it doesn't matter how the model is built or how many number of errors you make, because at the end of the day, we are all here to learn. And no matter where you are stuck, I'm there to help you. If I'm not there, Google is there to help you. So you're always learning, right? So once you're done with the project, once you have built the project end to end, you are the only one who will know what you have done. You're the only one who knows that how did you navigate through the project, and how have you built it, and what impact you have brought through this project, right? Once you're done with that, then we go on to the next step of including that in your resume. And I'll give you a detailed, session on that as well, that how can you include your project in your resume, what pointers can you include, or how can you include, right? Along with that, you must have noticed that there are a lot of recruiters in LinkedIn, and they notice the work that you do. They notice what you put across. So here is where we are going to take advantage of LinkedIn, right? And what we are going to do is in your bio, or in your experiences on your LinkedIn profile, you can include this project in the same manner how you are going to include in your resume. You can write pointers of what you have done, what you have solved, and how have you done that, and what impact you have created. And then additionally, you can also post. So you can create a post which is fancy enough, and you can use multiple templates for that, and say that I have been working with Tutort solving this problem for them, where we have created a personalized dashboard for the interns which correctly predicts their salary package for the upcoming drive, and helps the interns upskill themselves and gain a better hand at the placements. And you can then involve screenshots of the dashboard or screenshots of the code. You can tag me, you can tag the tutor, and gain more attention towards your post, and gain more recruiter attention, because at the end of the day, you're here to learn and you're here to grab the opportunities, right? So we can do multiple such things, and then encourage everyone to do this, and to own the project and utilize your project to build more on it, right? Clear? Everyone clear till here? Or everyone agrees with me? Any specific question, any specific doubt that you guys have till here? Anything that it can be, maybe that how to include in your resume, or how to use the project, or what to do in the project. It can be anything. But do you guys have any doubts, anything? Okay, Faisal says no. What about others? Not now. Okay, okay, great, great. Cool. So let's proceed with the problem statement then, right? Cool. We have defined our current state. We know our future state, and we know what's the gap, or what is the difference between our current state and future state, and what to do, right? So what are we trying to exactly do? We are trying to exactly predict the salary packages for our interns, right? We are trying to predict how much salary are they going to get. Now, here comes some theoretical concepts that I'm going to go through towards our class, and I'm exactly going to help you navigate through solving the problem. And we are going to do it together. And also, before jumping onto the code, we are going to understand concepts theoretically and understand problem solving theoretically. Right. First step that we are going to do is understand it very, very verbally, and then conceptually, and then code wise. Okay. Now imagine let's imagine we are solving this problem right away, right? We are solving this problem right now, and we have this problem statement wherein we are trying to predict the salary. Now the first step that you do while solving the problem is understand what is the problem, and what are your objective that you're trying to solve, which we have done, that is done for us, right? So I'll just keep typing in over here. So objective, and what are we trying to solve? So what? So this part is done for us, right? This part we have completed, right? Okay. Next is what is the path that we are taking to solve it. Now for that we need data, right? We need a lot of data to understand what can go ahead with in predicting the salary. And in terms of data, we have our features which are like age, which are like their previous salary, their coding experience, their skill sets, their accessibility, etc., etc., etc. So this part is also sorted, right? Everyone with me till here? Yes, everyone with me? Okay, great. So once we are done with this, we now know that we have our age, we have a years of coding, we have a previous salary. So maybe build, I can solve the problem or build upon the problem, saying that I want to understand what percentage of interns are are employed right now, and what percentage are not employed. Maybe the second step is that I want to understand. These are all part of understanding the data that we did last time, right? I want to understand, if previous salary is affecting my future salary or not, which it is, right? It is a highly dependent variable, right? Then is age a factor? Is coding experience a factor? So we are building number of hypotheses on that, and then we are testing it out to understand which feature exactly corresponds or correlates with my target value. So that is what I'm doing to pave my path. So once I know that, yeah, these are the things that are helping me predict my salary, I'm actually going ahead and building a model to predict the same. Once I've built my model, I know that what are the, yeah, future salary packages that I have for these students. Now, understand it clearly, right? When you're predicting the salary packages, these will be very specific numbers. Okay, this will be numbers like maybe 58596. It's a very specific number. So for you to quote a number, will it be like, I'll give you two options, okay? You guys answer me. Will it, as a student or as an intern, if you get a forecast on how much you're eligible to earn in the next placement drive, you have two options. In one, which you are getting a very exact number of something like I said, 585956, and the next thing is a range, something around 7 to 8 LPA. Which do you think is a more convenient method of presenting your forecast to the students or to the interns? Which one do you think is the better one? Okay, then Lakshmi says range. What about others? Range. Faisal also says range. Range with confidence intervals. Okay. Okay. Yeah. Okay. What about others? Only three people? I mean, again, remember that we are brainstorming it together. So it's completely okay. Even if you feel something else, if you want to suggest something else, completely open to that. Right? Okay, range. Everyone agrees with range, right? So we are going to not only predict the salary for them, but we are then again going to divide it into a range for the students so that they have a better idea and it's more presentable to them, right? And then we're also going to give them recommendations. Now, how to give those recommendations, right? Now, this recommendations can be maybe something that comes up on my mind is this recommendation can be given on two factors, internal factors and external factors. So you see how I'm breaking down the problem. I'm always structuring and breaking down the problem, right? I'm doing it step by step. Now, internal factors can be something like which are the features or which are the columns, features, variables that have contributed most to the salary. So let's say previous salary, coding experience, and the skills that the person has is contributing most to the salary prediction. So based on this, we can see that if these are the features that are contributing most to the salary prediction and better salary prediction, then I can maybe suggest something like, you know what, uh, yeah, it is something like feature selection, Rupesh. It is something like feature selection where I know that okay, if out of 20 features, top five features, these are my top five features which are contributing most to my salary prediction, then I'm going to build my recommendation based on top five features. So then we are going to see that on the highest salary packages that my model has predicted, what were the values in what were the most unique values on those top five features, and then give them recommendations or give interns the recommendations based on that. So we have to give them recommendations, right? This is the internal factor. And my external factors can be something that is related to my market trend. Something like right now, I know that Python is one acquired skill that is going to help you in your data science related jobs a lot. Or maybe, problem solving is something that you should upskill a lot. Or maybe we can take, assessment for these interns from time to time, and whichever lacks for them, we can do a recommendation for them a lot, right? So this is something that we can build on. So now we have the range of salary prediction, and now we are building up on the recommendation list as well. So what do you guys feel about it? Does it sound doable? Does it sound interesting and structured? Yes. Again, if you don't agree with me, you can also type in a no. But yeah, please let me know your thoughts. What do you feel? What more recommendations can go in, or how can we fill the list of recommendations for them more? Any ideas? What do you think can help the interns more? Okay, so meanwhile that you guys are thinking on what more can help the interns, what I can show you is an end output. So I can tell that my end output will always look like this, wherein I'll have the dashboard. Here maybe there will be name of the intern, details, which maybe includes the employment details and the assessment details for this particular intern. There will be these kind of details over here. Here can be the upcoming placement details. What is the upcoming placement that is coming up for them? And forecasted salary range, right? Forecasted range, right? And here can be upskilling points of what can that person work upon. So this is somewhat how my end output will look like. How does this look to you guys? How does the end output or end result looks to you guys? Does it look like something that can solve their problem or solve the problem that we are aiming to? Organized. Okay, Faisal says organized. What about others? Can I get a yes from everyone? Or can I get your viewpoint? We are all doing it together. Come on, guys. Let's be more interactive. Let's uh solve the problem together. Right? Okay, only two people responded. What about others? See, this is the main part that we are trying to solve. Yeah. We need to avoid the unnecessary feature with adjusted R square. Yeah, definitely. Definitely. There comes the part of feature selection and feature importance. We are going to talk about it, Rupesh. Definitely. Your point is taken. Cool. I think we have our outcome ready with us. I think we have what we are trying to solve, how we are trying to solve, and how the output will look like. Right. So verbally, we have solved the problem. Right. Can I get, you can also react, guys, if you can't, if you don't want to, chat, you can also react. So you think verbally we have solved the problem, and this is how you are going to talk your problems through in your interviews as well. So I just gave a depiction of how you can talk your problems through in the interviews as well. So you think we have solved the problems verbally? We have an outline ready with us? Yes? Cool, cool, cool. We will go on with quick responses. Yes? Okay, great. Now, we'll go on with some concepts. Verbally, we have done this. Now we have to do this while, technically. For us to do this, we have to understand what we are doing, right? Now, before I start, I want to know how familiar you guys are with machine learning or regression as a problem. How familiar you guys are. If you are familiar, you can type in a yes. If you're not, you can type in a no. It's absolutely fine. That will help me set up the pace for the session. Okay, Faisal says no, Monica says yes, 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 familiar. Okay, so would you like me to describe regression from basics or just start off advanced? Okay, Rupesh says advanced. Okay, what about others? Little overview. Okay, Advanced. Okay, cool. What about, okay, others, please let me know in the chat box. Meanwhile, I think I'll go ahead with and give a little overview so that others who are, unaware of it, or others who are not familiar or wants a little overview can have, right? Okay, cool, great. I'll start from the very, 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 very basic. Okay. So we have our data with us. We have the data that we are problem solving with. And there is something which is called features, right? Features are basically my data points or columns that are going to help me with understanding the thing that we are trying to predict, right? So we are trying to predict the salary. We are trying to predict the salary for my interns, right? So when we are saying that we are trying to predict something, we are setting a target, right? So this becomes my target variable. This is what we call as target variable, also known as your dependent variable. Okay. And all the other features which are helping me predict the salary, okay, those features are called as my independent variables or my independent features. So in the terms of machine learning, we always divide our data into dependent and independent variables. Independent variables are denoted by X. That's a common notation. And Y variable is basically my target variable. Okay. So this is how we divide our data set. Now, we will go on to the testing part later, but this is how we divide our data. Now, in machine learning, there are some kind of learnings that my model gets trained on. Okay, so there are two types. First is basically my unsupervised learning, and second is my supervised learning. Okay, how many of you are familiar with supervised and unsupervised learning? Are you guys familiar with supervised and unsupervised learning? I'm sure you guys have done a lot of projects and a lot of classes till now. So, yes, great. So can someone tell me what is supervised learning? Learning with labels. Okay, yeah. What about others? I'll wait for your response. Defining target variable. Okay, cool. Great, great, great. Okay. Yeah. Just for the people who are not, unsupervised learning is where whatever I'm predicting has no labels. Unsupervised learning is something where we have labels to our data. Labels mean something that we are predicting is known to us, right? Like for example, we are trying to predict the salary, so we know what we are predicting, right? So there are two type of supervised learning. One is classification and one is regression. I think most of us are aware of what is classification and what is regression, but just for the sake of revising, classification is whenever we try to predict in terms of classes or labels. For example, yes, no, true, false, zero, one. These are all labels, right? So that is classification. And regression is like when we don't have a particular class or a label, but we have numbers. So when we are trying to predict in terms of numbers or continuous variables, that is what we call as regression, right? For example, in our case, we are trying to predict salary. So salary is a number that we are trying to predict. So it becomes my regression problem statement. So this is like the basic overview on overview on the thing that we are working on. Now comes to regression. Okay. So before understanding regression directly, we are trying to understand the concepts of regression. Okay. So let's say this is my X, which is my independent variable, and this is my Y, which is my dependent variable. So there will be multiple marks of y that we're trying to predict for salary, and there will be multiple marks for x. Let's now consider that we only have one independent variable, maybe say age. Okay, age is my only independent variable based on which we are trying to predict the salary, just for the sake of example. Okay. So we would have some data points on X, right? We will have some data points on X, maybe something like something over here, something over here, something over here, something over here. Yeah, these are all my data points that is scattered through my entire X and Y, right? So the aim, or what we are doing through regression is basically trying to predict the salary for my data points that we have. Now for the existing data, so for example, the person whose age is 15, we know what is his salary because right now the data we have gives me the details. But what if a new data point comes in? What if a new data point comes in, let's say 35? We don't know what will be the Y for that, right? That is not there in my data. That is what we are trying to predict with a regression problem statement. So all we are trying to do is establish a relationship between our variables. Establish a relationship between our variables, right? So our main objective over here is to understand how or what is the best fit line between my data points, right? So objective is always to find the best fit line that describes my data the best. Okay. So what do we mean by best fit line? Basically, these are my data points, right? So there will be some distance. For example, this is the line that we have drew, L. L is the line that we drew, right? So these are my data points, right? So whatever is the distance from this data point to this line that we have established for my data, I am just going to take the sum of these distances. I'm just going to square them and take a sum of these distances and see that for which line I'm getting the least sum. And that will basically mean that this is the closest that I can represent my data into, and that is basically going to be my best fit line. And these distances, or this distance of the data point from the line, is what we call as residuals or residual error. Everyone clear till here? Everyone following me till here? This can be a bit advanced to some of you, so please let me know if everyone is following and if it is easy. Easy till here? Okay. Our aim is to understand it in the most easiest possible way. Okay. Cool. We have our residuals, and what our aim is to is basically to get the best fit line. We have the least residual, right? And for residual, what we do is take the sum of distance between the points data. Cool. Okay. So this is our objective. This is how we fit the line. Now, how to fit the line and how to get the best fit line is what we tune the model for, or what we train the model for. This line L that we have drew is represented by a mathematical equation, right? We all have heard about this equation, and we when we were studying maths and in our basic, we know what is this line, right? It's y equals to mx plus b. Do we assume that our x is linearly separable, or do we test for this? That's a good question, and I'm just going to answer about the assumptions as well. Okay, let me take the assumptions first since you pointed that out, right? Cool. And now, for us to work on this linear regression, there are certain assumptions that we do. Okay, and definitely we test our assumptions before performing it completely, and we see that these assumptions are being followed. It's okay even if you know about the data. It's okay even if you don't test them out. If you're completely aware of the data, but in certain cases we test them out. Okay, so the first assumption that linear regression clearly states is that there should be linearity, which means that the assumption is that the relationship between our variables should be like a straight line. So the line that we drew right now is a straight line, right? L is a straight line. So when we plot our data on the graph, it should look something like it is following a straight line, and that basically describes the linearity. If, for example, I would have had a line something like, I'll just change the color. Let's say we have a line which is representing my data in this manner. So this is not a linear relationship, right? This is not a linear relationship, and it looks, if it is a curve, then we can't fit a linear regression into that, because that doesn't represent my data well, right? That doesn't help me predict my, a salary that I'm trying to predict well. So linear regression says that there should be linearity between my variables. Second thing that linear regression says is independence, right? So, what does it mean by independent? It means that my x variables should be completely independent. That means they shouldn't be dependent on each other. So, that just means that the age of the person should not be dependent on whether that person knows coding or not, which is not the case, right? Someone age 35 may know coding or may not be know coding. There is no dependence on that. So, that is basically my independence. Then there is also a point of normality, which states that my data should be in a normal distribution, which is something like for you. And how do we do this on multiple dimensions? That is again a good question, but let me just complete my assumptions and I'll answer your question. Okay, so what is a normal distribution? So normal distribution is somewhere where my data looks like a bell-shaped curve. Whenever my data looks something like a bell-shaped curve, that is something that we tell is a normal distribution. So how many of you understand normal distribution? I would love to know that first. Yes, only Rupesh says yes. What about others? Yes, everyone understands the normal distribution, right? So my data should be normally distributed, which means my mean, median, and mode should all be in the same line. So that is what my normal distribution states. So these are some of the assumptions that linear regression has. Now, first things, we assume that these are true for our data and only build our linear regression model, which is true in our case. Second thing, how do we do it on multiple dimensions? Because right now we are just doing it for age, right? Age is just one dimension that we are working with. While we are working on a real-time data, there will be multiple dimensions and there will be multiple columns and features, right? So it is not humanly possible for us to plot it out or see so many dimensions, and that is exactly where machine learning comes handy. And we do this through a model which is pre-trained and built on, and that does the work for us rather than we doing it manually. So I hope your question is answered, right? Everyone with me till here? Everyone understanding the session? Easy till now, right? Easy, right? In real life scenario, we would expect some features to be normal and some not, right? Exactly. Yeah. Then in real life situations, some features will be normal and some will be not normal, but we'll try to keep them as normal as we can. And if something is extremely skewed, we'll have to bring it back to the normal form before we fit into the data. If we fit a skewed data, which is not in normal form to the model, my model is obviously not going to get my predictions at the perfect way that it would have, right? So that is where our data pre-processing comes in. That is where we do our EDA, process our data, understand our data, and then build the model. If it would have been such an easy exercise, everyone would have just started out with building the model right away. But we won't do that. We understand the data. We understand which features are mostly correlated with my data. We understand how my data looks like, if there is outliers, if there is normal distribution or skewness. We treat the data, pre-process the data likewise, and then there's also pre-processing on processing on variables, like categorical variables can't go into pre-built models, so we have to treat them also. I'll come to it how we treat them, all of it. But yeah, there's a lot of pre-processing that we do before we build our model, right? Cool. So we were on a linear regression model, and this is how my linear regression, the line that we are trying to fit in is represented mathematically. So this is my, can someone tell me what is y? Before I answer, can someone tell me what is y? Salary. Okay, salary and dependent variable, right? Exactly, dependent variable. So this becomes my dependent variable, which in our case is salary, right? And becomes my independent variable, which in our case is age, right? And m here is slope. This is what we call as slope. And b here is my intercept. What is slope and what is intercept? So slope basically tells me that if I move one unit, I'll just change the color. Slope basically tells me that if I move one unit in my x-axis, how much difference will it make to my y-axis? That is what my slope tells me. So this becomes my slope, which is m. And what my intercept basically tells me is that whenever my x is 0, what is the value for my y? So this area, this line or this difference that we see that is represented by red is becoming my b, which is my intercept, right? Everyone clear with the equation? Yes? Great, great, cool. So this is like the basic of my, linear regression. This is what we are trying to do. We have for every value of x, we are trying to predict what will be the y, and we are trying to fit. Our objective is basically to try to fit the best fit line for my data where my residuals will be the least. Now for residual, we can use something which is called as RMSE. I'm just going to go with RMSE for our illustration purpose. There is sum of square, there is SS, which we call as SS. There's also root mean square error, which is RMSE, which is basically root of my mean squared error. Squared error is basically my residual, and the root of those okay, I'll just make it simple. So residual square, which is summed up. Wait, I'll just retype it. Yeah, summed up of our residual square, R square, divided, because it's a mean, so divided by the total number of observations, which is n, and the root of it. So that becomes my RMSE. So everyone familiar with RMSE? Everyone clear till RMSE? So this is how I'm going to see that how well my data is being represented by my line, how well my predictions are. Yes? Can I get a quick yes from everyone? Great, great, cool. So then there is something which we call as cost function. How many of you are, familiar with cost function and cost function for linear regression to be specific? How many of you are familiar with this? Yes, no? Are you guys familiar with cost function? Okay, Pratik says yes. What about others? Have you heard the term cost function before? Yes. So can someone tell me what is the role of cost function? To calculate slope and intercept. or rather to minimize. Can I say that? Rather it is to minimize, to reduce the error, right? Right? Everyone agrees with me? The objective of cost function is to minimize my slope, which is my m, and my intercept b, right? Okay, yeah, great. So I'll represent my cost function with j. So j basically is equal to 1 by 2m, and then there is summation from I equals to 1 till m. So m is basically the total number of data points that we have. So for example, if we have 500 rows, then m will be 500, right? Here, this into the residuals that we have. So it's basically the xi that we have minus y that I have, I square. So this is basically my cost function. So for every value of, for every value of slope and, intercept, we try to see that what is the best cost function that we can develop for a linear regression to basically reduce my error, to basically see that how better we can get at predicting what we are, right? So that is what we have conceptually for linear regression. So everyone clear till here? Can I get a yes if everyone is clear till here? Cool. Great. So we have done a lot. We have actually, understood linear regression. We have understood what it does and how it does. And now comes the importance of EDA and data preprocessing or feature selection. Okay. So EDA will basically help me analyze and explore the data to the core. So we'll know which features have what importance in my data. We'll have what are the insights that I have from my data, and this will help us in our data storytelling. And then we have our data pre-processing. So until unless we pre-process our data, we cannot fit our model on that. Okay, we cannot fit our model on unprocessed data or mismatched data, right? So this is for my machine learning model. And then there is feature selection. So this will basically, or feature importance. So this will basically tell me which are the features which is helping me the most in contributing to my target variable that I'm doing. So this will help me understand that and build the model even more better, right? So herein, while we, validate our model, like we did our RMSE, etc. So this is for validation. I take some brighter color. Yeah. So this is post building our model. We'll do our validation, right? So you saw that we were testing out our RMSEs. We were seeing that how much our data is changing from what it was, or how well my prediction was, right? So for example, whenever this is basically if the x value is which is 35, so what my model will do is just see that what is the corresponding y value for this particular value. So this becomes my predicted point, and this is the y value that I have predicted. So we'll see then in actual how much difference is there with my predicted value and with my actual value that I was there in my data, because I'm trying to validate, I'm trying to understand how well my model is fit, right? So for that, we need to divide our data into two parts, the training part and testing part, right? So how many of you are aware with splitting the data and why we split the data into train and test? Yes, no, anything? Everyone aware of validation, model validation? Come on, guys. Can I get a response? Yes. Okay. Okay. Great. Cool. So basically, the data that we have, if I, for example, if I have 500 rows of data with me, okay, I fit the model on that, I've trained the model on that, and I know that my model has the best line possible. Okay. Now, for me to see that if my model is predicting, is being able to predict correctly, if if I test the model, or if I ask the model to predict on the same 500 rows that I have trained it on, do you think that will be a valid way to check if my model is performing well or not? Do you think that is a valid way? Pratik says no. What about others? So I'll just repeat the question. So let's say we have 500 rows of data with us, and we have built our model. We have built our linear regression model on this 500 rows of data. And now put to test that whether my model is performing well or not, whether my model is being able to predict or not. I am testing it on the same 500 rows of data. I'm trying to see what it is predicting for the same 500 rows of data. Will that be a valid way to check if my model is being able to correctly predict my data or not? If my model is built well or not, will that be a valid way? Will cause overfitting. Okay, no, 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 right? So everyone agrees with me that will cause overfitting, or something we will won't be able to validate if my model is correctly built or not, because you cannot test the model on the same rows that it is built on, because it is obviously going to give the same answers, right? So this won't be a very optimized way. So that's why we divide our data into train and test. So on the training part, for example, we divide our data. So let's say we have our data this way. So what we do is maybe we divide it into 70% of train, where we use 70% of the data to train, and the rest 30 part we'll be using to test. So when you test your model, or when you ask your model to predict on the unseen data, or the data that it has never come across earlier, it will be able to give predictions in a more unbiased manner. So for these 30% of data, I know what was the actual salary that they got, and now I'm going to see that how much my predicted data point is far or near from the actual value, and that is going to give me an estimate that how well my model has been predicted. So that will give me an estimate that how well my model has been able to predict the data points, and also how accurately it is being able to predict. Right. So this was the concept of splitting the data into training and testing to validate my model. Right. Everyone clear till here? Yeah, we can judge the model performance. Absolutely. Everyone clear till here? Can I get more yes before we move on to the coding part? Okay, great. So if everyone is clear with the concepts of linear regression, we can now move on to the coding part and see all of it that we discussed through our codes, right? So I'll just stop presenting this, and I'll share my screen. Is everyone being able to see my screen? Yes? Okay, great. Cool. So I'm doing all of it through Jupyter Notebook. You can do through Collab or you can do through your specific platform as well. For me, Anaconda Jupyter Notebook works well, so I'm doing it through that, right? First steps first, we are going to import all the libraries necessary. So pandas, NumPy, Matplotlib, and Seaborn is something that we'll be working on closely. So I imported them. Pandas is for data manipulation. NumPy is for working with data structures and more like mathematical calculations as well. Matplotlib and Seaborn both are for visualizations, right? Everyone aware of all the libraries? Okay, great. Cool. So my first step is that I've imported the libraries. Now I'm going to read the data. So I'm just going to use a read CSV function that is going to read my data, and this is how my data looks like. We have already seen the data. We already know how my data looks like, right? So if you see there is an unnamed column which is extra to us is not necessary. So what I did is basically removed that column and selected only the columns that are necessary to me. Okay. And now if I see my columns, everything is what I exactly want it to be, right? So I'll just check the shape of my data with dot shape. This will basically give me the number of rows, which is 7, 3, 4, 6, 2, and the number of columns, which is 14, right? So this is the, advantage of using pandas. Pandas has a lot of data manipulation functions, which directly helps me with analyzing the data very, very closely. There is also something which is called as panda profiling. I'll just type it in the chat box, which helps you give a report of the data exactly. So it performs a first level analysis for you, and it tells you what the columns are about, how well related the columns are with each other, and how it basically creates a report on the data. So all the analysis that we are trying to do, we basically can do all of it through panda profiling. So that's like a auto ML library that can also be used. So yeah, so that was a quick trip. How many of you were already aware of panda profiling? Okay, Rupesh was aware. Okay, okay, Faisal was not. Okay, cool. You can explore on panda profiling more. It's an automated library which basically helps you in generating your report, helps you in understanding the data one level down with just one line of code. Cool. Okay, I forgot to ask you guys before we move on with our session. Do you guys want a break? A 10 minutes break? Okay, Faisal says no, he doesn't want a break. Rupesh also no. Okay, everyone agrees with no. Great. No one needs a break. That's a good thing. Okay. Uh, Next up, we are going to see a little bit info about my data. So this is a info function of the pandas, which basically gives me the data's info. So we have all the columns with us. We have their data types and the constraints. So if you see over here, my have worked with column has a bit of missing data, right? Because my shape is 73462, but for this, we have a bit of missing data, right? So if we want to maybe look at it in a better way, we can do something like is null dot sum. If you see, I've worked with has 63 missing values. So all of us are aware that our data needs to be complete, right? Missing values basically don't represent a well-formed data. And there are multiple ways to impute my missing values, right? We impute through multiple modes or multiple ways. Maybe if it is a numerical data, we can impute with mean or median. If it is a categorical data, we can impute with mode. So according to all of it, can anyone tell me for these 63 values, what can go well, what can be imputed, or should we not impute, or is it important for us to impute it over here? I want to know your viewpoint on these 63 missing values because it's an important data point, right? Impute with mode. Dhanlakshmi says impute with mode. What about others? Here we can ignore as we have enough data. Okay. What about others, guys? Come on. Categorical type of data should be imputed with mode. Yeah. Anyone else? Use KNN imputer. Yeah, those are like the techniques, but conceptually. Cool. I think, yeah, I mean, all of you are not wrong. Everyone has a fair point over here. But for now, what I'm doing is I'm going to keep it aside. These 63 data points are comparatively lower than the points that we have or than the rows that we have in our data. So I'm going to keep it aside for now. If my model is not performing well, I can come back and all the time rebuild it, right? So I'm going to keep it like that and go on to my next part of describing my numerical data. So dot describe is a function which basically describes the numerical data for us. So every column that it identifies as numerical data, it describes that for us. As we can see, it gives us the count of variables. It gives us the average. It gives us the standard deviation, mean, 25th percentile, 50th percentile, 75th percentile, and max. And this gives an overview on the data, right? This gives a very, very important overview on the data, actually. So, for example, I know that the average years of coding for all the interns with us is something around 14 years, right? And the pro coding experience is something around 9 years. Also, I know the average salary over here is 67 750, which my interns have currently right now, or as their part of their previous salary. So can someone tell me something, some more interesting insight out of this data? Can you guys notice something, or can you guys figure out some important points from here about the data? Outlier? Okay, Rupesh says outlier on computer skills. What about others? Okay, that meanwhile that you guys actually find out some insight from this description, I'll just take a 2 minute break. I'll just get my water. Okay, I think I'm back. What about what? No one has any answer or any insight that they generated. Did you guys understand what description function is doing? Yes. Can I get a yes if you guys understood this part? It's a statistical summary, right? Checking continuous data. Exactly. No one else with any more answers? Okay. Okay, cool. So few things to note. Definitely, it is a statistical summary of all the outliers, or I mean, all the continuous variables that we have with us. Okay, we have some answers. Years Code Pro also has outliers. Okay, employment should come in category. Exactly. Exactly. Very, very rightly pointed. Uh, Great. So, though these pointers are right, I mean, it is a statistical summary for all the continuous variables, etc. But if you see employed and employment, both of them are categorical columns, right? But it is in the form of 0 and 1. But Python understands it as numerical value because it is in the form of 0 and 1, and that's why it has pointed it out in a description function, which is not relevant to us, right? Then the next part is definitely there is some kind of outliers in computer skill. Now, how do we understand that there is a outlier? Definitely, there are box plots or IQR ranges to understand there are outliers. But from here, right from here, we can understand if there is an outlier or not. If you see, the minimum computer skill is 0 and maximum is 107, which is a huge number, right? Similarly, you guys had also one more data point which says that there are years of coding which is 50 is the max and min is 0. So again, you noticed it as an outlier, but can someone tell me if years of code and years code pro actually has outliers or not? Does theoretically or conceptually it makes sense that it has outliers? Do you think? What do you think? Will you term it as outlier? Rupesh says it is important. What about others? And Lakshmi says no. No. Aparna also says no. Not to be treated as outliers. Exactly, guys. Exactly. So, though obviously over here we can see it as outliers because the numbers are huge and it is not matching with the range that is there. But if you have noticed from the earlier session that we had, our age group has two type of data points. One is greater than 35 and one is less than 35. So if a person has an age of greater than 35, is it not normal for that person to have around 50 years of experience at max, like 50 years of coding experience? Is it not normal? Exactly, normal, right? So will we now treat them as outliers? No. Right, Rupesh says no. What about others? Did everyone understand this point? Did you guys understand my question? Yes, no, anything? Um, okay, I'm not sure what happened, but suddenly I'm not getting any response. Okay, I need to know if you guys understood the logic behind not treating them as an outlier. Did you guys understand why we are not taking them as an outlier? Here's code and here's code pro. Please explain again. Definitely, yeah. See, so in our age variable, we have seen that in the last class as well. So let's see it once more. Okay. Years of okay, do you agree that years of coding is directly somewhere related to age, theoretically, conceptually? It is related to age? Yes? Okay. If I do a value counts, which basically counts the unique values in my data point, if I do a value counts, so I have less than 35 and have greater than 35, right? And we have a lot of data points which are greater than 35. So if a person's age is greater than 35, it can be anything. It can be 45, it can be exactly 36, it can be 60, it can be 50, it can be 70, anything, right? So if a person of that age is there with us, is it not normal for that person to have 50 years of coding? Or if that person, for example, has started coding right from his schooling, is it not okay for one or two person as an exception to have 50 years of coding? Possible, right? Possible. Exactly. It is possible. And that's why we are not going to treat it as an outlier. Everyone cleared with this point why we are not treating this as an outlier? Okay, great. Cool. Moving on. I've just done a matplotlib inline so that my plots are plotted within my coding range. And then I've done a histogram plot for all the, all the variables that we have, all the numerical variables that we have with us. Okay. And what's a histogram doing for us? It's basically plotting the distribution of the data for us and showing us how my data looks like. Okay. So if I run it, if you see, okay, obviously employment and employed are categorical, which doesn't make sense. But there is years of code. So can you see the distribution over here? So we have a lot of people who are from the range of somewhere around 5 to 20, 5 to 15. Lot of people with 5 to 15 years of coding experience. And again, for years of coding, it's zero. Pro years of coding, it's 0 to 10. Everyone agrees with me? Everyone is being able to interpret the data from this graph? Yes? Okay, great. So can you guys tell me how does previous salary look to you? How does the data of previous salary look to you? What do you think? What do you think most of the data, where does the most of the data lie in previous salary? Less than 10. Yeah, exactly. Exactly, right? And same with computer skills also we have our data, right? Cool. Now, you might have a question in your mind that how we have our statistical summary for data, which is numerical or continuous. How do we do it for categorical variable, right? So for that, we just have a parameter which says include equals to object because object represents categorical data. Even in our info, we would have seen object data type, right? Object represents categorical data type, right? And when we do that, when we do an object equals to, include equals to object parameter, we have a description for our, categorical variable as well. So can anyone tell me the insights that you can get from this particular piece of code? Anything relevant to us? Anything? Unique is important for category features, number of values. Yeah, definitely. But any data point that you notice can be relevant for in our problem that we are trying to solve. I'll wait for 1 or 2 minutes. I want you guys to notice the code and understand the insights out of it. Anyone did anyone notice anything? Country US has uneducated on top. Undergraduate. I think we are talking about undergraduate. Python outweighs other skills. Exactly, guys, exactly. This was what I was looking for, right? So you guys have rightly noticed the data. So if you see, Python has something which is on the top. So if have worked with comes as one of the important features for us, we can definitely recommend Python as an upskilling tool to the interns, right? Tying back to our outcome or tying back to the structure that we are actually trying to build, right? Everyone agrees with this point? Can you guys like tie the problem? Can you guys now see how we are solving the problem? Okay, great, cool. So once we are done with our description and statistical summary, we can do a number.
Yeah,
Sorry.
one question here. Sorry to interrupt.
Yeah.
Like have worked with maybe some person has only skills Python, right?
Yeah.
And some other person have 2 or 3 skills including Python.
Yeah.
This one is basically counting only Python or also the person having multiple skills with Python.
So if you have seen the data, if you have seen the data from the data frame that we have, it is not a separated column right now, right? It has a number of skills attached with it right now, right? So definitely the ones with just Python is getting calculated, but there would be a lot of points where a person has Python along with the other skills as well, right? So that is not getting counted over here because the data is not separated, right?
Okay.
Yeah, but still, if Python comes at the top, still can be recommended with it, right?
Okay. Got it. Got it.
Yeah. Can't it result in imbalance in a hard have worked with variable? I didn't get your question then, Lakshmi. Are you saying that since we have a lot of Python variable with us, it will somewhere imbalance our data? Are you trying to say that? Yeah, that is there. But also it will contribute more towards salary prediction also that we are going to do, right? So it again depends that how much imbalance is there, right? If but for our case, it is a skill that is highly required. Even conceptually, Python is a very very demanding skill set right now. So most people will definitely have Python. We can't over do that part, or we can't ignore that part, right? So it makes sense to have Python as one of the top skills over here, and it won't rightly imbalance the whole prediction, but it will contribute. We can term it as it can contribute more towards the prediction that we are trying to make. Do you agree with me? Everyone clear till here? Everyone understanding the session till now? Okay, great. So now, like I was saying, that your EDA is your most important part in your whole problem solving. Here you are trying to understand and explore the data to the most. Here you're trying to work with the data the most, right? And herein, when you're doing a media, when you're trying to do a EDA, it is highly recommended that you do it in a very structured manner rather than just doing it haywire, right? And for that, what I recommend you to go through is what is called a different type of analysis: univariate analysis, bivariate analysis, and multivariate analysis. Always start with univariate analysis, and analyze your target variable, analyze your independent variables. Then go with a bivariate analysis, wherein you are analyzing multiple data points or multiple features with respect to your target variable, right? And then your multivariate analysis, where we are, analyzing multiple variables together. Cool. So for example, over here, what I've done is that for all the categorical variables that I have, so I've selected D type equals include equals to object, which is basically selecting all the categorical variables. I am doing a count plot. So this is basically a univariate analysis. So when I do it up, you see I have age. So like we have already seen from our last session, a lot of people have age less than 35. So our data points with less than 35 age is more, right? So that's the insight that we get from here. Second, we have an accessibility of no. So a lot of people have no accessibility to the job boards that we had discussed. Then again, we have a lot of undergraduate people over here, and this is again dependent on the education level. Similarly, we have our gender, a lot of men. And this is basically just count plot. It's counting the number of values for each of the classes that we have. Similarly for mental health, and similarly for main branch dev and not dev, right? Everyone clear till univariate analysis? Okay, so now what's the importance of this univariate analysis, right? Here in two, we can check multiple things. We can check imbalance for our data. If our data is highly imbalanced, and imbalance is something that we check only with respect to a target variable. If my data is highly imbalanced, which means if for example, if there are two classes with the data, yes and no, if 90% of my data point is yes, it will basically be biased, right? And this is only with respect to the target variable, right? So in that case, we try to balance the data, and there are multiple techniques to balance the data. We can sample the data and bring both of them to 50-50 by either reducing the 70 to 50, or increasing the 30 to 70, and then making it 50-50. So these are called as sampling techniques. Where we either subsample it or oversample it to make it 50-50, right? So we can check for imbalance of data. Second thing, we can check that if any of the data points over here has extremely high values. For example, in our accessibility there is extremely no data points more than yes, then we can also generate recommendations over here. Like for example, we know that we have a lot of undergraduates that are working with us, so herein we can customize the recommendations likewise for undergraduates, since a lot of people are undergraduates and are trying to switch, so their years of coding experience will also be less, like we have seen over here. A lot of 5 to 15 years of experience also here is there. So these kind of things will help us generate our recommendations, and that's why EDAs are very important, right? Cool. Everyone agrees with me? Everyone on me till here? Cool. Same way we can do our bivariate analysis over here. So I've just done a simple box plot for x equals to age and y equals to employed. I'm saying for with respect to age, how is my employed variable looking like? And if I see there's not much difference, right? There's no much such difference in the values. It's equally dependent on employed variable as well, right? Similarly, we can check for outliers also, and we can check for multiple bivariate analysis plots as well. I've just done some for the explanation of it, but as a task, you are going to work with the data. And before that, everyone could access the data, right? Everyone has access to the data. Yes. Okay. So did you guys get a chance to check the data on your own? Yes. No. Anything? Did you guys get a chance to explore the data or to see the data? Not yet. Okay, I'll highly recommend you guys to look at the data and explore the data and do all of those things that we are discussing on your own. Only then you can build your project on your own, right? And all of this EDAs that we are doing right now, I want you guys to complete the EDA before the next session, and only then we are going to proceed. So your task is basically to first start with your data story. Second, generate a lot of insights from the data and state them out with your visualization graphs. Can I expect that from everyone? What about others? Can I expect that from everyone? Great. Cool. So herein for illustration purpose, I've done only very limited graphs of univariate and bivariate analysis. But for you, I want you to plot a lot of graphs. I want you to do a structured EDA. I've just said you how to do first your univariate analysis, second your bivariate analysis, and third your multivariate analysis. And then give me insights that you get from the data. Give me pointers that are very, very crucial to the problem that we are trying to solve. Right? Okay. Now we'll move on to the next part wherein we check for outliers, right? So herein I have plotted my box plot, and this which we call our IQR range. So this box of the blue box that you see is basically my IQR range or my interquartile range. Anything that flows or follows out of this range is what we call as or term as outliers. So here in previous salaries box plot, we can see some outliers over here. But do you guys, now that we had a very logical discussion on a lot of pointers, do you guys think this will be a outlier? Do we need to be worried about this outlier? Rupesh knows. What about other people over here? No, no. Can someone tell me why no? As age is greater than 35. Okay. What about others? People having coding experience 50 expect more salary. Exactly. This is a salary, most of the data are captured. Okay, so as you can see, this is a salary column, right? And people can have more experience and more salaries, right? It's very normal for someone to have extremely high or extremely low salary. And that is why we can't consider salary as a number to be an outlier, right? Everyone agrees with me? Yes, no, anything? But skill number is outlier, right? Yeah, we'll come to that. We'll come to that. But till here, if everyone agrees with me, can I get a yes from everyone? Everyone with me? Everyone is hearing the session, right? I hope you guys didn't sleep already. I know it's late in the night, but I hope you guys didn't sleep already. Okay, great, great. Okay. So next up, we have years of coding. I've again box plotted it. Same way I have done for years coding pro as well. And we see there are a lot of outliers, but we have already discussed how they are not an outlier for us exactly. And then what I've done as a part of EDA is that I've grouped my country with previous salaries. I'm trying to see for each of the countries that we have, what is the average salary that is being generated from each of the salaries. This is just for me to generate insights, and likewise, you can also do a lot of insight generation. I'm trying to see that what is the average salary from each country that is there. And I've just displayed the top 30 countries, right? So I've done a group by on country. My aggregated column is previous salary and mean is the calculation that I'm using. And then I've just sorted them and, displayed the top 30 countries. So I think it's very easy and interpretable, right? So can someone tell me the insights from this particular piece of code? US's average salary is in top, right? What else? What else? Come on, guys. This is the interesting part, right? Looking at the data and just getting analysis and insights out of it. This is what we are mainly working with, right? So I'm expecting more insights from you guys. Can someone tell me more about this? We need to check the people count also per country. Yeah, we can do that. We can do that as well. Maybe US has a lot of people. That's a very good point, Rupesh, actually. Maybe US has a lot of population and that's why a lot of salary, but also US as a country's GDP is higher, right? So the salary range for US will be higher. And if you see US, Israel, and Switzerland are the top three countries with maximum salary package that we have, right? So we can easily state this insights that any person who is from these top three countries can expect the highest salary package possible among all the interns that they have. Can we easily state that statement? Is everyone with me till here? Can we state the statement? Okay, great. Cool. So you all are with me till here. So these are basically type of insights that you can look for. You're just trying to see more out of the data. You're just trying to see what is making more sense in the data, right? Similar way, I have checked the next thing, which is my data distribution, but because for now that we are processing also my data along with my exploration, I am also trying to see if my data is distributed normally or not, right? So for example, over here, I have plotted my previous salary. So I have this graph over here with me. Just give me a moment. Yeah. So this is how the graph or this is how the distribution for previous salary looks like. Can anyone tell me if this is a normal distribution? No, Rupesh says no. What about others? Is this a normal distribution? No. Pratik says no. Princey says no. Rupesh a little bit export. Okay. So what do you think this data is? It is skewed, right? It is skewed. But is it left skewed or right skewed? Right skewed. Exactly, right? It is a right skewed data. I'm glad you guys could identify this. So it is a right skewed data. So when my data points are accumulated on this part of the day, this part, left part of the graph, which means that there is a skewness on the right part. So it's a right skewed data, right? So for treating this data, you can do, yeah, mean is more than median over here. Exactly. So for treating this kind of data, we can do multiple type of transformations over here. So herein comes your skills of transforming your data into a normal distribution. Again, for linear regression, as we know that our data needs to be normally distributed, right? So can someone okay, before that, can are you guys aware of transformations? Are you guys aware of data transformations? Yes, Rupesh says yes. What about others? Cool. So there are multiple transformations that are available. I mean that are usually done. A very popular one is log transformation, where we take logarithmic value of each data point that we have and basically transform our data to a more normalized form. There is something called as reverse transfer, reciprocal transformation, where we take reciprocal of each of the data points. There is someone also there is some transformation which is also known as Box-Cox transformation. So what I've used today is Box-Cox transformation. I'll speak about it, but first let's see how it is transforming my data. So I've just created a another data frame and copied my data to it. df. I've imported stats, typy.stats, which is a module which will help me do the Box-Cox transformation. And I've applied Box-Cox transformation only on the previous salary column. Very, very easy, right? And then I have plotted the column again. Now is the data looking better to you? Now is the data looking more transformed to you? Yes, better? Close to normal, exactly, right? So how many of you were aware of Box-Cox transformation? Please explain. Yeah, sure. No, okay, cool. So Box-Cox transformation is again a type of transformation that we work around with. It is basically, again, the concept is same. I'll just try to annotate. Yeah, the concept is again the same. It is trying to transform my data to follow a normal distribution. So what it says is that my column, so let's name it y, will be equal to y to the power lambda minus 1 divided by lambda. Just give me a moment. Yeah, just give me a moment. With no chat box. Yeah, is equal to y to the power lambda minus 1 divided by lambda if lambda is not equals to 0 and natural log of y if lambda equals to 0. So lambda is a coefficient for Box-Cox transformation where lambda ranges from, it's a threshold, right? That for which the Box-Cox transformer basically checks that for which value of lambda am I getting the best normal curve that I can for my data. So it ranges something from -5 to +5, and it basically sees for each threshold or each value of lambda, which is the best form of normal distribution that I can get. So this is what my box transformation looks like. It's a very simple, easy transformation. So everyone got what is a box transformation? Yes. Can I get more? Yes, if you understood box transformation. Cool, cool. I'm just going to clear all the drawings over here and proceed with the code. So now my data is transformed, right? So similarly, we have, skewed data for years of coding and years of coding pro as well, which I'm sure now you can transform and make it look like a normal data more. Um, and then next up, I've done just a scatter plot for years of coding and previous salary, which has a lot of clustered data points and is not giving me any insights, right? So this is again a very important part of EDF. There will be a number of graphs that you are going to plot, which is not going to make a lot of sense for you. And that is okay. That is really very okay for you to plot such graphs. We are just going to vomit and torture all the insights out of the data. And that's why we are trying to do an exploratory data analysis over here, right? Cool. So just proceed. The next thing that I've done is grouped my whole data by the column employed and aggregate function median. So I basically found the median for previous salary, computer skills, and years of coding for the people who are right now employed and not employed. So if you see the median for years and code and previous salaries really not dependent on their employed status, but the computer skills is somewhat differing from here. So these are some of the insights that you can look for. Similarly, I've done a same plot, by bivariate plot for age versus employed. So we can see that people who are employed and less than 35 age, there are more people basically who are less than 35 and employed, right? So we have a lot of employed people, and definitely there will be definitely there will be a lot of coding experience for these people as well, which again means higher salary expectations as well, right? So we can generate similar graphs for columns like gender as well. Everyone clear till here? Everyone clear till here? Can I get a quick yes? Okay, great. Next up, I have created a heat map, which is basically a correlation heat map, which basically states what is the correlation coefficient or how correlated my variables are with each other. And this again is done only on the numeric data points, only on the numeric continuous variables, right? So can anyone tell this graph and say my most correlated data points? Can anyone tell me and give me a glimpse of this? Years of code pro with years of code, definitely. And it will be correlated, right? Because they have they have similar things. But yeah, what about others? Should avoid one. Yeah, computer skills and employed, exactly. Computer skills and employed is highly correlated with each other. Somewhere years of coding also with previous salary, right? Yes, no. Exactly, right? So did everyone understand this part? Yeah, yes, but not high. Exactly. So did everyone understand this correlation part? Okay, great. Cool. So next part of the pre-processing that we are working on it with is transforming my data. Now, we have a lot of categorical data as well with us, right? And as we all know, my machine learning model will not be able to interpret categorical data. So in that case, we have to work around and change my categorical data into numerical data. Some way we have to do this, right? So can anyone tell me if you guys are aware of how to process categorical variables into numerical variables? Can you process categorical variables into numerical variables? Yes, no, anything? Use dummy variable. Okay, what about others? Get dummies. Obviously, get dummies, dummy variables, these are all the methods, right? But there is something which is called as encoding. Encoding basically means that um, encoding basically means that we are trying to change our numerical data, I mean categorical data into my numerical data, right? So there are different types of encoding that we have. We have one-hot encoder, we have label encoder, etc., etc., right? So herein I have used one-hot encoder, but you can also use something like label encoder. So label, and I'm just abbreviating it as LE, and I'm abbreviating or one-hot encoder as 1HE. For target, we use label. Yeah. Okay. So what label encoder does is that, for example, let's say we have a column called fruits. Okay. And for fruits, we have values like apple, we have banana, and maybe we have something like orange. Okay. So what label encoder does is that it creates ordinal relationships without actually giving any numerical meaning to the data. So it will have the same column fruits, but with ordinal relationship, and by changing my categorical data into numerical data. So it will assign a number with it. So maybe apple will be 0, banana will be 1, orange will be 2. So here there is no actual, dimension to the data. There is no actual magnitude that is assigned with the data. That doesn't mean that 2 is greater than 0 over here. Here 2 represents orange, 0 represents apple. So this is what we call as ordinal relationship or ordinal data, right? This is what we call ordinal data. So it transforms my data numerically to, categorically to numerically. But whereas what one-hot encoding will do is basically create multiple columns with the available classes or available categories that we'll have. It will create one with apple, it will create one with banana, and it will create one with orange. And wherever, in whichever row there is apple, it will give 1, others will be 0. Same way, for if there is banana, it will give me as 1, orange will be 0. If there is orange, others will be 0 and orange will be 1. So this is what one-hot encoding does. So eventually, we are just converting all the categorical variable to numerical variable, right? Everyone clear with this? Is everyone clear with this? Can I get more yes before we proceed?
One thing to discuss.
Yeah.
For the column like education level, we
Hmm.
have some order in it, right? So we will
Yeah.
use signal encoding in that.
Sorry, I didn't get your last part. What did you say?
In the column educational level, ED level,
Yeah. Yeah.
there is an order like master, undereducate,
Hmm.
PhD. So I think
Yeah.
ordinal encoding will be best for that part.
Yeah, so again, it depends on the type. Both label encoding and one-hot encoding will actually do the same thing. The only difference happens is that with one-hot encoder, it increases the number of features. And sometimes when we increase the number of features too much, it can cause a lot of overfitting of the data, or my model won't be able to predict very accurately, because a lot of features have been fed to it. So there, label encoding helps. And in terms of ordinal relationships, somewhere all of the categorical variable will have a level of ordinality in them, right? So label encoding and on one-hot encoding both make sense over there. But the only point is that we can't abnormally increase the number of features also.
But that is okay. But here is also we have a weightage in the column, right? In the education level, like the master having more weightage than the normal person or the under.
Yeah, yeah, there is some kind of weightage, but do you want your model to understand that weightage to understand the salary, or do you want your model to understand the relationship between a person who is undergraduate and 5 years of experience and who is maybe higher studies and 15 years of experience? Like, won't won't giving a weightage to particular data points in the pre-processing part create a bias to the model?
Okay, but okay. For some point it is okay, but for some other points it is making sense. Okay, we can use one hot encoder. No
Yeah,
issue.
yeah. Even you even use label encoder. It is actually, both are actually making sense to you over here, right? So it is just like depending on your number of features and also depending on the use case that you're working with.
Okay, okay. And in the ordinal also we are not increasing the feature. We are just increasing the, we are just making the values in that particular.
Yeah, yeah,
Okay.
exactly. Cool. I think once we okay, so that now that we know what is one hot encoding and label encoding, let's just see the code. So herein I have used the pre-processing module from sklearn and hot encoder from the same. And for all my categorical variables, first I've displayed all the categorical variables. So these are all my categorical variables, right? Um, if you see, it is correctly representing all my categorical variables. Now for every categorical variables, I am first checking what are the total number of unique values that are there in each of the categorical variables. So for age, it's 2. For accessibility, it's 2. Likewise, for everyone, we have the number of categorical variables. Now here, over here, I have used one hot encoder and because I had to explain you about this. But don't you think a label encoder will work better over here? Because country and have worked with have a lot of unique values, and creating that many number of columns can disrupt my model, right? So don't you think label encoder will work better over here? Yes, Rupesh says no, but it will increase the number of features, right, Rupesh? If I have almost like what 700k values over here, if I create 700k features, won't it create disruption in my model performance? We should avoid this column, okay, even for country, right? So there are two ways to do it. Okay, what I have done is that for all these columns which have so many number of unique values, I've just taken maybe the top 10 values that is there, and I've only created the features for all top 10 values. For example, out of maybe out of 50,000 values that we have, if only 2 or 3 values are getting repeated I mean, if only 2 or 3 values are getting repeated the most and the others are just a rare occurrence of values, I'll give more importance to those 2 3 values, right? So that's why I've created top 10 features or top 10 encoders only for the values which are being repeated the most, and ignored the others. So that's one way, and the other ways is to you can do a level encoding, right? Everyone clear till here? Is everyone clear till here? But label will increase unnecessary weightage. That we'll have to see with the data, right? Once we have built the model, we can see that if that is creating an unnecessary weightage or not. We can do that, right? We can check with the features contribution to the model, right? Okay, everyone agrees with me till here? Cool. So what I've done is for every categorical variable, I have basically encoded them into the top 10 values for every. So for example, for country, I've taken top 10. For have worked with, I have again taken top 10 values over here. And based on those top 10 values, if you see, the number of features are getting created. Same way I've done it for all the categorical variables that we have. Accessibility, education level, gender, mental health, main branch, I've done for all of them. And at the end, if I see my number of columns, it has increased so much, right? But we also have to remove, now we have to remove the categorical variables which we no more need, right? Because we have encoded them already. So I've done that. I've filtered only the variables that I need and removed the other ones. You can also use a delete statement. I've just selected the columns that I need. And now if I see my data, it looks something like this. And here I come to an end with data pre-processing. So is everyone clear with data pre-processing and EDA and what we are trying to do? Yeah, analyzing top 10 rows is not top 10 rows, but mostly like top 10 values, or top 10 values of the value counts. I've not taken top 10 rows, but I've taken top 10. So I'm doing a value counts, right? So in value counts, it will always generate the, high to low. And in high to, because I've done ascending equals to false. So in high to low, it will basically take the top 10 repetitive values, right? So for example, what I'm trying to do is I'll just show you. Let's do it with country. That will make more sense. Yeah. If you see here, in descending order, it states the top 10 countries. I mean, it states the number of values being repeated, right? So US, there are a lot of data points for US. Then there's Germany. Then there is India, etc. So if this way I take the top 10 rows, won't it make more sense, Rupesh? And also for others. Everyone clear till here? Everyone clear till the data pre-processing and EDA part? Yeah, we can do that. Yes, exactly, right? Cool. So I think we are very much on time. We have actually crossed the time. So only building the model is left right now with us and validating and understanding the model as well. So I'll keep this model building part for the next session and I'll stop sharing my screen for now. But I want to know from you guys that did you guys feel the session was useful? Did you guys proceed with your problem statement till now? You can give me an honest understanding. But I would love to know from each one of you, since we have come a long way till here. Okay, Rupesh says yes, very useful. What about others? When do we have the next session? Will that will be informed to you about the next session, most probably day after yesterday. So that will be informed to you. Okay, learned a lot, very useful. Thank you so much. So now can I expect a submission from all a submission from everyone? Can I expect your data story and insights from everyone? Can I expect some kind of task from everyone? Because again, at the end of the day, it's your project, right? Can I expect that before the start of next class? Yes, no, anything? Okay, I'll try to arrange the session a bit late so that you guys get time to do the task. Yeah. Okay. Great. Great. Thank you so much for being there with the session. I'll try to arrange the session a bit late so that you guys get time to complete the task. But then you guys have to come up with all the tasks, right? I want to see submission from everyone. And until unless you do your project on your end, it makes no sense to sell the project, right? You won't be able to sell the project in your interview if you don't do it, right? Cool. Thank you so much for attending the session. I'll see you guys in the next session. But till then, keep practicing, keep learning, and let me know if you have any doubts or anything. Okay. Thank you so much, guys. Thank you so much for attending. Good night.